In this lesson, we are looking at general motion in a straight line. We have a particle P moves in a straight line, and there are three different stages, it appears. And our first question, we're looking for k. K is a constant, and we're being given time and velocity for the three stages. So, we look at our first stage. Velocity is 5t times t minus 2. We replace that with 4. And you'll get 40. And we know that k is a constant. So our first stage, 5 times t, we know that that's a quadratic. It's going to have a curve on it. It's positive, so it's going up. And so k must be 40. And we look at our graph next. We've just sketched a velocity time graph for this. So what I've just told you, the quadratic first, then a constant, and then a linear graph comes next. So from 0 to 4 seconds, we had the quadratic. And we didn't have a constant in it, so it starts from the origin, from 0. Our second stage, from 4 seconds to 14 seconds, was 40. And lastly, we've minus 2t plus 68. That's going from 14 to 20 seconds. So when you get this kind of question, just break it up and do a quick kind of minor sketch first, and then do the one that you'll actually have in your exam, or try and do in your mind. We'll probably see a few questions like this anyway, where you break up into different stages. And it's actually a really good question because it encapsulates what this whole topic is anyway, with the graphical and algebraic ideas involved. So there's our sketch. Of course I didn't sketch it, but that's what you would have done. And what comes next generally is the calculus. So we don't have constant acceleration or velocity or anything like that. So we must use differentiation or integration. And this little mnemonic here will help you to remember which direction you should go. But if you just think about it a little more deeply, you should be able to see either way. So think about these minor details deeply is a good way of looking at that. C, find a set of values of t for which the acceleration, so we're going from velocity to acceleration. So again, just thinking about what that is, it's differentiation, which is dy over dx. On the right hand side you'll see there the conventions, conventional writing. It comes from Leibniz did that one, so that's his conventional writing. So our a, our acceleration, is 5t squared, so it's 10t minus 10. And of course that's between 1 and 4. So the set of values for where it's positive, of course between positive 1, so t is greater than 1 and less than 4 within that boundary. You can verify that with the algebra, with the equation, and with the graph. I've just color coded the graph there for that. So just looking at the graph now, we see there's 3 different stages. Generally what comes next is finding a distance. So we have the total distance. So find the total distance travelled by it within the full interval from 0 to 20 seconds. So from 0 to 2 are our first limits, and that will include, so 5t squared minus 10t will also include from 2 to 4. So all the way from 0 to 4, we have to treat it as two separate integrated parts, because one is below the x-axis. Again, write out your parts there. And then after that, we have two other shapes. Might be an easier way of looking at it. We have a rectangle and a trapezium. So using the formula that you know for that, put in those details as well. So the height was 40 and the base was 10. Base meaning width if you want. And then we have 14 and 20, the same height. Or width, I should say. The width here is 6. So 40 plus 28, divide by 2, or find half of that, times our 6. And of course, from here on out, it's just clearing up these little details. So we'll integrate this now. So it's add 1 is 3, 5 divided by 3, t to the power of 3, minus 10, 2. So 10 divided by 2 is 5. And we'll just put our little boundaries there as well, 2 and 0. And you can plug that in your calculator, of course, to find that. If it has a boundary of 0, you know that it just takes away from 0. So put out your workings either way when you're doing this in the exam. 4 and 2. So plus 400 plus 204. And add them all together, and you'll get your distance of 644 meters.